Hello friends, welcome to Concepts of Geology, the online platform. We are doing a live session on structural geology practical problems. Okay, many of you were attending the live class on the Google Meet, but some of you are also demanding for the recorded classes. Okay, and that's why I will record and upload some demo classes on this YouTube platform. So this is the fourth class of the live session, and today we are going to learn about the calculation of thickness of a strata or bed on a flat topography. But before going to the topic allotted for today, we will solve the problem which was given on the last day. Okay, that was on the 3-point problem on uneven topography. Okay, so let's begin. The problem was, we are having three boreholes A, B and C. They are drilled on a hilly terrain and they have encountered an ore body at 700 meter, 1000 meter and 650 meter depth respectively. Okay, how the A, B and C is located on the ground, that is instructed here. The borehole B is located north 50 degree west of A and the distance between them is given. The direction and the distance of C from B is also given. Okay, and the RL, that means the elevation from the datum plane, or suppose here mean sea level of the three borehole collar or the topography. Okay, that is also given here. So with that much of information, we need to solve this group of questions. Okay, first we need to draw a borehole location plan in 1:10,000 scale. Definitely 1:10,000 means 1 centimeter in my map will be 100 meter in the real ground. Okay, after that we need to find out the attitude of the ore body, and with that we are having some more questions which we will gradually move on and try to solve. So on the third class we have discussed the fundamental of the 3-point problems on uneven topography. Okay, to solve this kind of problem, we need to first deduce the reduced level of the point where the borehole is touching the target bed. Okay, what was discussed on the last class, that suppose we are having a borehole C here. Okay, and the depth of the borehole is this much, 500 meter, and this point C, I mean the topography, is at elevation of suppose 900 meter from the mean sea level. So what is needed to calculate here is the RL of this point. Okay, to calculate this we need to subtract the borehole length from the total elevation. Okay, so the RL of this point equal to the total elevation subtracted the borehole length. Okay, so here it is 900 minus 500, so the RL will be 400 meter, and this is positive. Here it was also again positive, but here we are having a value which is negative. Okay, why the negative value is coming here? Because the target bed is going below the datum plane or mean sea level where the borehole is touching it. Okay, so that means wherever we are getting the reduced level value positive, okay, that means the borehole has encountered the target bed above the datum plane or here above the mean sea level. And when I am getting the negative value of the reduced level, that will be when the borehole is touching the target bed below the datum plane. Okay, this is happening for this A borehole. Okay, so this was the fundamental. After having the reduced levels of all the boreholes, we will draw the triangle, construct the triangle, and we will try to locate the borehole in the borehole location plan. Okay, so first see here the RL of the three boreholes A, B and C, they are calculated. Okay, the length of the borehole A was 700 meter and the reduced level or the elevation of the topography was 650 meter. So the RL will be 650 minus 700, that means negative 50 meter. For B it will be negative 750 meter, and for C it is coming positive 150 meter. Okay, because C has a depth of 750 meter and the elevation of the topography is 800 meter. Okay, so 800 minus 650 will be positive 150 meter. Okay, so that means definitely from this negative positive values we can anticipate that the borehole C has encountered the ore body above the datum plane, while the borehole A and B, they have punctured the datum plane and they have encountered the ore body below the datum plane. Okay, that's why their RL values are coming negative. So after calculating these reduced level values, we will keep it. Okay, and now we will try to plot the three boreholes in our borehole location plan. The scale of the location plan will be 1:10,000, that means 1 centimeter in my map will be 100 meter in the real ground. Okay, suppose I have taken the north in this direction, this marking is the north marking. The first instruction which was given for drawing the borehole location plan was the borehole location point B is located north 50 degree west of A. Okay, now this north 50 degree west means 50 degree west of north, so it is 360 minus 50, that means it is towards 310 degree. Okay, if I am talking about the whole circle bearing, it will be 310 degree, and in the quadrant bearing it is north 50 degree west. So north 50 degree west means 310 degree. Fine, I will take one point A arbitrarily anywhere in my map. Okay, suppose I have taken the point A here, and I will draw a 310 degree angle. Okay, and that angle will be the direction of the B. Okay, so this small angle is 50 degree. Okay, so the B is located north 50 degree west of A. Okay, so I will draw a line on this direction. Suppose I have drawn this line. Fine, so in this line somewhere the B will be located, but I don't know where actually the B is located. Now to find out the exact location of the B, I need to know the distance between A and B. Okay, so the distance is given 800 meter. According to my scale, 800 meter means 8 centimeter. Okay, so I will measure the length 8 centimeter along this line. Okay, suppose I have got the 8 centimeter length here. Okay, so that means this is the exact location of the B. The B is located north 50 degree west of A and 800 meter away from A. Okay, so I have plotted the B point also on my map. After B, I will try to find out the position of C. The instruction is C is at south 15 degree west of B. So definitely south 15 degree west means 180 plus 15 degree, that means 195 degree. Okay, in whole circle bearing. So I will measure 195 degree angle and I will draw a straight line along this direction. Okay, so in this direction the instruction is given here that the distance between B and C is 1100 meter. So that means according to my scale it will be 11 centimeter. So at 11 centimeter I will cut that line. Suppose my 11 centimeter is coming here and the exact position of C is coming here. So that means now I have plotted point A, point B and point C on the plan, and this is the borehole location plan drawn on 1:10,000 scale. Okay, so the first question is solved here. The second question was to find out the attitude of the ore body. So that means the strike deep and deep direction of the ore body. So to find out the strike deep, we need to use the RL values. So at the point A, the RL value was minus 50 meter. Here it was minus 750 and here it was positive 150 meter. So that means the borehole B has encountered the ore body as maximum depth from the datum plane, and the borehole C has encountered the ore body at the maximum elevation from the datum plane. Okay, so this maximum and minimum value in arithmetic sense, if you think this, minus 750 is the lowest value and positive 150 is the highest value. So we will get this minus 50 meter value in between them. So that's why I have decided to graduate this line, okay, this CB line, and I will project this point A on this CB line, okay, and when I am getting this projection, so that projected point will be connected to the real A point, and that will be one strike. Okay, now how can I project this? If you use the arithmetic process, it may be somewhat harder here. Okay, why? Because the gap between these two is 900 meter. Okay, I mean the vertical gap between them is 900 meter and the length gap is 11 centimeter. So if I divide, it will be a fraction. That may be a problem, so I will not go into the arithmetic process, rather I will go into the trigonometric one. Okay, so let's see how to find out the projection of point A on this CB line by trigonometric method. So first I will draw the CB length here. Suppose this is the CB length. Okay, this point is C and this point is B. Okay, I will try to find out the appearance of the ore body in this CB section. So at the point B, the ore body has been encountered on a depth of 750 meter. Okay, the RL was minus 750, means it will be going on depth. So I will draw a 7.5 centimeter line vertically below the point B. Why 7.5? Because according to my scale, 7.5 centimeter means the 750 meter. Okay, so this length will be 7.5 centimeter, and on the point C we have encountered the ore body at positive 150 meter. That means it will be at elevation. So this length is 1.5 centimeter. That means in real ground it will be 150 meter. Okay, so this value is positive and this value is negative. Fine. Now I need to find out the 50 meter depth value. Okay, because the borehole A is having a 50 meter negative reduced level value. Okay, so negative means in this construction definitely I will need to find the A point on this side. Okay, here I will never try to find it on this side. Why? Because this is the elevation side. I need to find out on the depth side. Okay, so this is the depth side. What I need to do is I will first draw the 0.5 centimeter length here. Okay, why 0.5 centimeter? Because this is the scale factor. So 0.5 centimeter means 50 meter. So I have drawn a 0.5 centimeter length here, and I will take my divider out from my geometry box and I will copy this length, and I will try to fit the divider, I mean this copied length, in this portion of the diagram. Okay, so this needs a hit and trial method. You do hit and trial and try to find out where exactly the divider is fitting. Suppose the divider is fitted here exactly, so that means at this point I can get the projection of A on this CB line. I will measure this length. Okay, suppose this point is P, so I will measure the CP length and I am measuring it from the C end. Okay, try to remember this. I am measuring this point from the C end. I will advise you to don't measure the line with scale, rather you copy this length with your divider again. Okay, so copy this CP length with your divider and move to the borehole location plan. Okay, so this is the borehole location plan. Now I have copied the CP length in my divider. Point one end of the divider on the C and find out where the another point P is coming. Okay, so suppose P is coming here, this length is CP. So that means what? This point is the projection of point A on this CB line. Okay, so clearly here I will have the RL of the ore body minus 50 meter. So here I am having a minus 50 meter RL value, and here I am having a minus 50 meter RL value already previously. Why? Because A point is having minus 50 meter value. So if I now connect this point and this point through a line, I will get a contour line, and where I am drawing it? I am drawing it on the Actually I am drawing it on the map view, so it is a map strike line. And if you are thinking on dip, you are drawing it on the inclined ore body. Okay, so it is a contour also for the ore body. Okay, so this is called a stratum contour. Okay, so they are actually same type of terminologies. Here I will call it a map strike line. Why? Because I am drawing it on the map, and now it is working as a strike line. And the same time, if you are thinking on the 3 dimension, we are drawing it on the inclined plane. Okay, after drawing on the inclined plane, we are projecting it on the map view, and when we are projecting it on the map view, it is becoming the map strike line. And the original line which is drawn on the inclined plane, that is called the stratum contour. Okay, actually this line is not existing in the ore body itself, rather it is conceived into our mind. Okay, this is a geometric line, not a physical line. Okay, so that means now we are having one strike line, this one, and this strike line will have a value of minus 50 meter. Always try to remember that all the values you are having, they are negative here. Okay, so this is minus 50 meter MSL. Whenever I am having the orientation of this line, okay, this is a strike line, I can draw more strike lines. All the strike lines will be parallel. So from this point B, definitely one strike line will be passing, and that strike line will be having a RL of minus 750 meter. Okay, so I will draw a parallel line which will pass through this point B, and I will write here this is minus 750 meter MSL. Okay, this is again negative. Now from the point C, positive 150 meter strike line will pass. Okay, so again I am drawing a straight line which is parallel to the strike. Okay, so all these are strike lines, but they are having different depth or elevation values. Now it is very easy to measure the orientation of this line with respect to north. Suppose this is the north, so measure this angle. When we will do this problem on your copy, you will find that the strike is becoming 75 to 55 degree. Okay, clearly the two ends of the strike will have a 180 degree difference. Okay, now for complete the answer of the second question, that means the attitude, I need to find out the dip and dip direction. Dip direction can be measured. I am talking about the true dip. This will be just perpendicular to the strike. Okay, so you can measure this, or you can find it by adding 90 degree with this 255. So the dip direction will be 345 degree. Okay, so that means it is dipping towards northwest quadrant. Okay, to find out the value of the dip, we need to measure this perpendicular distance between the two contour lines. So measure it with your scale. It will be almost 2.2 centimeter. Draw a 2.2 centimeter horizontal line. Okay, and what is the depth fall between these two contour lines? It is here minus 50 and it is here positive 150. Okay, so that means the gap between the vertical gap between them is 200 meter. Fine. So I will draw a 200 meter line according to my map scale here. Okay, so this is the vertical fall. So 200 meter will be 2 centimeter. So I have a horizontal length of 2.2 centimeter and a vertical length of 2 centimeter. Construct this triangle. Okay, so this is the appearance of the ore body along the true dip direction. Okay, or a direction which is perpendicular to the strike. Okay, and measure this angle as the angle of true dip. So it will be near about 43 degree. This is the answer of the second question. So the attitude of the ore body is this one. Okay, the third question was where the ore body will outcrop nearer to sea. So the ore body's outcropping means I need to find out the 0 meter strike line. Okay, because on the 0 meter strike line I need a borehole actually which is encountering the ore body on a 0 meter depth. So that means I don't at all need a borehole. The ore body is already on the surface. Okay, so to find out the 0 meter strike line, you do again that geometric drawing. Okay, suppose the 0 meter strike line is coming here. Okay, it will be definitely in between minus 50 and positive 150 meter. Okay, zero value will be in between them somewhere. So suppose I have got the 0 meter strike line here. So that means this is the surface. Now where the ore body will outcrop nearer to sea, so that means I will draw a perpendicular line from the sea. Okay, and I will measure this length and I will convert into my scale. So that will be the answer. That will be the minimum distance where I will get the outcrop of the ore body. Okay. The fourth question was a new borehole D is drilled 400 meter north of A. So this is the A, 400 meter north. Okay. You measure that length 4 centimeter, and at which depth we will encounter the ore body. Okay. So try to find out which contour is passing from this point, suppose. Okay. That contour value will be the depth where I will encounter the ore body. Okay. This will be with respect to the datum plane or mean sea level. So we have solved this type of questions on the last example also, on the second class also. So I am not going into deep with this type of questions. Let's move into the question number 5. Here it was asked that find the apparent dip of the ore body along this CB line. Okay, this was the CB line. So you measured the length of the CB line. Okay, you know this is 11 centimeter. So draw a 11 centimeter horizontal line, and what is the vertical fall? It is 900 meter. Okay, so draw a 900 meter vertical line, construct this triangle, measure this angle. Okay, so this is an apparent dip along CB direction. Fine. The sixth question and last question was a borehole E which is intended to drive vertical. Okay, that is located 300 meter due south of B. Okay, so move 300 meter due south of B. Okay, so that means 3 centimeter. Draw the strike line here. Try to find out the value of the strike line. It will be minus 454 meter. Okay, near about. And on this point E, I am trying to drill a borehole which was intended to drill vertical, but it is deviated and it is touching the ore body at 400 meter depth. So definitely from this contour value it is clear that here the borehole should touch the ore body at 450 meter depth, but I am encountering the ore body at 400 meter depth. So definitely the borehole has been deviated, and how much the deviation has been taken place, that is the question. To solve that, again I need to find out the perpendicular separation between these two strike lines. Okay, this will be near about 2.9 centimeter. Draw a 2.9 centimeter horizontal line here. Okay, and from here if I go vertically, I will touch the ore body at 454 meter. So draw a vertical line. Okay, and at 4.54 centimeter length we should have the ore body here. Okay, the borehole is deviated and we are having the ore body as 400 meter. So the deviation may be on this direction or on this direction also, but if I am going on this direction, I will touch the ore body on more depth, but I am touching the ore body at a lesser depth. So that means definitely the borehole has deviated on this direction. So draw a 400 meter length here. Okay, this angle will definitely be 43 degree because we are drawing this on a true dip section. Okay, now clearly measure this small angle as the angle of deviation. Okay, so this is the angle of deviation. This will be near about 12 degree. So these are the entire solve of the problem given. Okay, take a screenshot of these answers. Okay, and try to solve the problem on your own. So this was all about the previous question, and this is the time for the today's class. Our today's topic is the calculation of thickness of a bed or strata on a flat topography. Okay, so suppose this is the flat topography or horizontal topography, and I am having an inclined strata here, this one. Okay, this is the upper surface of the strata and this is the lower surface of the strata. Okay, now I may have different types of thicknesses here. Suppose this thickness is the true thickness or stratigraphic thickness. This is AP or T here, denoted as T here. This thickness, which is the vertical thickness, this is denoted as AP dash or T dash here. Okay, the amount of dip of the inclined strata is theta, okay, and the width of the outcrop here on the surface, suppose it is AB and denoted as W, okay. So these are the parameters given, and I need to construct the formulas, the trigonometric equations, to find out the T, T dash or W, okay. So I am having three variants here, W, T and T dash, and also theta, four variants, okay. So I need to make trigonometric relationships between this T, T dash, W and theta. Normally during the field work we will have this W, we can measure the width of the outcrop in the field, okay. We also can have this T dash length, because if I do a borehole, actually we will have this T dash length, but the problem is to find out the stratigraphic thickness, okay, or the true thickness of the strata, okay. So let's try to find out the trigonometric relationships between these factors in a flat topography, okay. Why flat topography? Because if the topography is not flat on this problem or on this terrain, I will have a different value of W, okay. So this width of the outcrop is actually depending on the topography. If the topography is sloping like this one, so I will have the length of W this one, okay. So this will be the width of the outcrop, okay. So that's why it is clearly mentioned on the problem that we are going to calculate the thicknesses of a bed on a flat topography, okay. Now first I am coming into the triangle APB, okay, this one. Here see, this angle is 90 degree. Why? Because this is the true thickness, and the true thickness is measured perpendicularly to the upper and lower surface. So this angle is 90 degree clearly, okay, and this angle is theta. Why? Because this is the amount of dip. So on this right angle triangle, this is the perpendicular, this is the base, and this is the hypotenuse. So if I am doing AP by AB, okay, so that means perpendicular by hypotenuse, that means sine theta. So sine theta means T by W, this length is T and this length is W, okay. So sine theta means T by W here, so T means W sine theta. So this is the first relationship. True thickness means width of the outcrop into the sine of the dip amount, okay. So clearly if I am knowing the width of the outcrop, okay, and the sine of the dip amount, I can have the true thickness. Where it is possible? When I am getting a correct outcrop or proper outcrop. When I am getting a proper outcrop, I can measure the width and I can measure the dip amount also with the clinometer. So there I can have the true thickness by this equation, equation number 1, okay. Now next, coming to the right angle triangle again, AP-B, suppose this one, AP-B, okay. It is also a right angle triangle. So this angle is right angle here. Suppose I am doing a vertical borehole from the topography, and I have touched the lower surface of the inclined bed here, okay, at the point P dash. So this is a vertical line, this angle is 90 degree, okay, and this angle is theta, the amount of dip, okay. So here this is the perpendicular, this is the base, and this is the hypotenuse. So AP by AB, that means perpendicular by base equal to tan theta. So tan theta equal to T dash by W. So clearly T dash equal to W tan theta. This is the second equation. The apparent thickness of the bed equal to width of the outcrop and into tan of the dip amount. So from this equation I can predict the thickness of a strata bed, or suppose unconformity or whatever, okay, in a borehole, if I am knowing the width of the outcrop and the tangent of the dip amount, okay. So suppose I am having an outcrop, I can measure the width of the outcrop and I can have the dip value. So I will do this equation to find out the apparent thickness of the strata. So that means it will be that thickness which I will get when I will do a vertical borehole. So this equation is very much important here. So now I am having these two equations, okay, T equal to W sine theta and T dash equal to W tan theta. Now I will divide 1 by 2 So this is 1, this is 2. So T by T dash equal to W sin theta by W tan theta. W I am cancelling. So tan sin theta by tan theta equal to cos theta. Why? Because tan theta means sin theta by cos theta. So sin will again cancel. So the answer is cos theta. So T by T dash equal to cos theta. So that means T equal to T dash into cos theta. So that means the true dip equal to apparent dip into cosine of the dip amount. This is the ultimate equation, okay, and this is the third equation. We can have the true dip when I am having the apparent thickness and cosine of the dip amount. By 3-point problem we can have the dip amount, okay, and we can have the apparent thickness in each and every borehole. So from that we can have the true thickness of the bed by this equation, okay. So this is the importance of this equation, okay. You try to memorize, or rather you try to construct this equation on your mind, okay. These equations will help to find out the thickness of a strata or a bed on a flat topography, okay. Always keep it into your mind that these equations are applicable in case of flat topography only. So these are all about for today's class, okay. Now I will give you a problem which you will do on your own, and you will post it on the comment section, or you will email me, okay. You may join on the live class also. Write me on the registered email ID of the channel, okay. I will provide the link how to join on the live classes, okay. Actually this type of classes are needed live interactions, but for the convenience I am providing some demo recorded classes here. So try to learn and grasp the concept as much as you can. Fine. So this is the problem given for today, okay. The minimum width of a limestone bed on which is measured on a flat topography is 53 meter. The same bed is having 45 meter thickness on a nearby cliff, okay. So that means if I do a borehole, I am having the thickness 45 meter. This is the apparent thickness, okay. The bed is definitely inclined here. When I am measuring the outcrop in a flat topography, this is 53 meters. So I am having the W here and I am having the T dash here. Try to find out the amount of dip on the limestone bed, okay. You use the equation which is appropriate for this. Second question is find the true thickness of the bed. Again use the equation. A borehole which is intended to drill to puncture the bed at its minimum thickness, okay. Minimum thickness means what? The stratigraphic thickness or true thickness, okay. At which angle it should be oriented? I will not give any hint about the question. Try to draw the profile section and find out this, okay. The fourth question is draw a profile section of the limestone bed on 1 centimeter equal to 100 meter scale, okay. So do it on your copy and post the answers on the comment section or send a mail to me, okay. Thank you for watching and showing interest on concepts of geology. We will meet again on the next class with a new topic. So goodbye till then and take care.